Quadratic inequalities are just going to be a combination of things you guys already know. So you know how to graph a regular linear inequality about whether it's going to be a dashed or solid line and which direction to shade. And we learned at the beginning of the unit how to graph a parabola or how to graph a quadratic equation. So it's just combining those two things you guys already know into now saying, okay, let's try to graph a quadratic inequality. So it shows you guys that you can have the 4 different inequalities, and that's just showing you the less than or equal to, greater than or equal to. So it just has those different signs for each one. Now it says when you guys are trying to graph this, don't make it more complicated than it needs to be. So if you're trying to graph a quadratic inequality in one of those 4 forms, just follow 3 steps. So actually graph the parabola using a dashed or solid line. So what you guys have to remember is the 3 forms that we talked about at the very beginning of the unit: the vertex form, intercept form, and standard form. So once you graph the parabola with the correct line, whether you're trying to include or not include the solutions, then you have to choose a test point, and based off that test point, the 3rd step is shading the solution region. So just remember that when you guys have an inequality, it's a region or multiple solutions. That's why we shade. It's how we show that there's multiple solutions. Everything that's shaded is a solution for the inequality. So for the most part, your equation is almost a lot of times just going to be in standard form. Remember, you can always put them in standard form. But so if they are in that form, you guys have to remember that in order to find your vertex, you have to use that formula x equals negative b over 2a. So if we look at the first equation, or the first inequality, x squared minus 3x, that's really x squared plus 0x minus 3. There is no b term. So if we're trying to find our x value, we'll say x equals negative 0, even though you really can't have a negative or positive 0, over 2 times a, which is 1. So this will give us 0. Let's find y. Now for most of the work you do for quadratic inequalities, as far as trying to graph them and find the solutions, periodically we just sort of treat them as an equation when we're trying to find the y value or solve for y. The inequality just lets us know that there's going to be a range of solutions. But as far as working with it and solving for it, you kind of treat it the same as an equation. So we'll just plug in the 0 again for your x and get negative 3. So your vertex is at 0, negative 3. So then we just need 2 other points so we can draw this thing. So I'm just going to plug in 2. So 2 squared is 4, minus 3 is 1. And then I can just reflect that over to my other side. Now, just like a regular inequality, guys, like if you were doing a linear inequality, based off of your sign is going to determine if the line you draw for your parabola is going to be dashed or solid. So since this inequality is just greater than, not greater than, or equal to, it's going to be a dashed boundary line. We don't want to include solutions on that boundary line in our answer. So then the last thing we have to do is shade. So just like before, when you had regular inequalities, you chose a test point, decided if it was true or false, shaded with respect to what you found. So I'm going to plug in 0, 0. So if I check 0, 0, I plug in 0 for y. Will 0 be greater than 0 squared minus 3? Yes. So since 0, 0 is on the inside, that's where I want to shade my solution. Okay, let's do our second inequality. So same thing again. Find your x value, so of your vertex, so x equals -4 over 2 times a, which is -2. So -4 over -4 is 1. Plug it in to get your y, and we just periodically treat it as an equation. So -2 times 1 squared plus 4 times 1 plus 2. So that'll give us -2 plus 4, which is 2, and 2 plus 2 is 4. So our vertex is 1, 4. 1, 2, 3, 4. And the rules still apply also, guys, if you're looking at your A. Since our A is negative, this parabola should be opening down, just like we said in the past when we had a regular equation and it wasn't an inequality, but still a parabola. The negative A does make it face down. So we just have to plug in one other point. So I'm just going to plug in 0. And then I would get 2. I can reflect that over here to that side. And this line is going to be solid. So I can test 0, 0 again. It's hard to tell, but it is on the inside of my parabola. So if I checked 0, 0, so if I plug this in and I check it, I get 0 is less than 2. It's hard to see my plus 2 over there, but it does work. So I could shade the inside of this parabola as well. So the overlap here is going to be where your shaded sections overlap, so right there in the middle. So any ordered pair in that section would be your solution for both of these inequalities. Any ordered pair in there would work for both inequalities. So here you're not really stating or giving me a solution, you're just graphing and showing me where the solutions are going to be. So why don't you guys try to do the first example, number 1.